Evening, everyone. Welcome to my first recording for the A-level syllabus. So I'll be taking you for all the A-level maths topics. I'll be doing topic by topic. So watch more or check more on my channel. So this is Mr. K. I'll be taking you for A-level syllabus 9709. Your AS and your A-level syllabus. But today we just want to concentrate on the AS, and we're going to look at the topic circular measure. So the topic circular measure is not a difficult topic, especially if from your O-level, because you find that 40% of this of the topic is built from the O-level syllabus, where you have to know in detail how to use sine rule, how to use cosine rule, how to use Chashaw tau or Soccer tau if you are given a right angle triangle, and now also you now apply it to length of arc, perimeter of a sector, length of a sector. So from O-level, given this first diagram, we know that this is a sector. And for example, to find the length of this sector here from O-level, which is AB, we know that length of sector from O-level, length of arc, from O-level is theta over 360 multiplied by 2 pi r or pi d. So in this case, we are saying length of this arc here. But from A-level now, because normally when we're doing these calculations, we're using radians. So we should know that 108 degrees is equal to pi radians. Okay, 180 degrees is equal to pi radians, which means your 360 here is equal to 2 pi. So to change this formula is 360 over theta over 360. But 360 now is equivalent to theta, sorry, I'm not sure what's happening to my pen. 360 is equivalent to theta over 2 pi multiplied by 2 pi r. And if you do that, you drop this, you cancel that. So you find that the length of arc at A-level using radians is simply given by theta multiplied by the radius. So in this case, the rad is 1, the radius is 10, so it's simply 10 centimeters, the length of this arc. Now, if we were to look at the length of the sector, so it's equal to length of arc from O-level plus 2 what? 2r. So length of this arc plus the radius plus the radius, length of sector, if we're dealing with sector now. Now, we say we have discovered that the length of an arc at A-level is r theta, so plus 2r. So that's how we find the length of a sector. The length of a sector is given by length of arc plus 2r. In this case, it will be 30. Because we're saying this, we discover that is 10 plus another 10 plus another 10. Okay. So that's what you need to know. Then for the area, you know that the area of this whole thing from O-level is theta over 360 multiplied by by pi r squared, because a sector is a fraction of a circle. So from this, if we were to change this in terms of radians, is theta over 2 pi theta over 2 pi 360 multiplied by pi r squared. The pi cancels and you simply get half r squared theta. So that's how you find that, half r squared theta. But now the challenge with this question, if we were to calculate that in terms of radians, we have to change, the angle should always be in radians. So the angle given is always the angle divided by, so it's always that angle divided by 180 multiplied by pi. That's how you change from degrees to radians. And 60 over 180 simply gives you a third pi in terms of your radians. That's the angle, a third pi. So you're simply saying, for according to the formula, half pi r squared. So according to this, we are saying half multiplied by r squared, which is 10 squared, multiplied by the angle, which is pi over 3, like that. That making sense? Okay. So basically, that's what you need to know. Then you simply apply that. Maybe let's look at one or two questions. This is just an introduction. We'll load more videos on this topic, dealing with exam questions. Now, in the diagram, AB is an arc of a circle with center O. AB is an arc of a circle with center O. Okay. The moment they say that, without reading further, this is the radius. So we know that from center to circumference, it means OA is also equal to the radius. OA is equal to OB because they are both what? Radii. Okay. Show that the angle AOB is equal to 1/3 in terms of radians. Now, AOB is this angle here, theta. If I was to redraw this here, another thing from circle geometry O level, if this is the tangent, because they said the line AB, XB is a tangent. So a tangent and radius always bisect at 90 degrees from circle geometry O level. So it means this angle here is 90 degrees, which makes this whole triangle a right angled triangle. So this is 90 degrees here. This is the angle theta in question we want to prove. So this here shows you that AO is equal to AO is equal to AX. So it means if this is midpoint, there, midpoint, it means this whole distance, this is R, this is R. So that is 2R, that distance there. And this is R like this. So now, because we are given the longest side of a right angle triangle, and we are given the adjacent, it means we can use cos. From O level, cos theta is always equal to adjacent divided by hypotenuse. The adjacent is where the angle is sitting, which is R. The longest side, R plus R, which is 2R. And that gives you half is equal to cos theta. But from O level now, we know that theta is equal to arc cos. Now, your calculator should be in radians. If you do that, you find that you get exactly pi over 3 radians. Now, express the perimeter. So we now know theta. Now, the next part of the question is that express the perimeter of the shaded, okay? Express each of the following in terms of r, theta, and root 3. So they're saying the perimeter of the shaded region. Perimeter of the shaded region is equal to what? Perimeter of shaded region. So it's equal to AX, let's agree, plus AB, sorry, plus XB, perimeter, distance traveled, plus arc AB. So this we have that's R. XB we don't have. Then the length of arc AB we don't have. But we said this angle here, we discover that is pi over 3. Let's do it slowly. So the easiest thing to find is the length of arc. So length of arc AB. Remember, we said is given by r theta. So this is r, the angle we have it. So it's theta 3r, or r theta doesn't make, it's just the same. R multiplied by theta over that is the length of the arc. So we now have the length of the arc. Now, what's left? So if we go back to this formula here, we said r plus length of arc, which is pi over 3r, plus, now we are left with AB. But we know that this is a right angle triangle. This is 2r. We discovered that this is r, this is 90 degrees. So to find xb, shorter sides, one of the short sides, we now say the longest side, 2r squared, minus the short side, which is r squared, like this. Then everything in big brackets, square root. Now, if we square this, we get 4 squared, okay, minus r squared, square root. And that, if you subtract, that gives you 3r squared, square root. But we know that the square root of r, so this is as good as, according to root 3 multiplied by square root of r squared. So that gives you root 3r. So this is plus root 3r. Because they're saying express the perimeter in terms of root 3 pi and r there. Okay, just hold on, guys. Express the perimeter okay, so it's up to you whether to simplify or not to simplify. We're saying length of arc, which is equal to 1/3 r, or pi r. It's up to you. Then we said length of bx, which we found 3 root 3. Then lastly plus r. Okay, so that's the perimeter thing. Perimeter, we are done. Now let's look at the shaded area. So the shaded area, now if we were to find the shaded area, okay, we know that this is pi over 3. Shaded area is the area of the triangle, OXB minus area of sector, OAB. So area of triangle, area of this triangle. We know that area of a triangle, I'll call it A1, is given by half AB sine theta, follow from O level, when AB, if you've got an angle, 2 sides and an angle between us, so we know that this is 2r and this is r, so we can apply that. So it means half multiplied by 2r multiplied by r sine the angle between them, which is sine pi over 3. Now, this cancels. Then you're left with r squared. Then find the sine 60 or sine pi over 3 in your calculator. Okay, so that sine pi over 3, sine 60 or sine pi over 3. That should be root 3 over 2. So this, if you check, it gives you, so multiply by root 3 over 2. So it means your area of that triangle, if I want, I can write it as root 3 over 2 squared, is the area of triangle in question. Now, which I called A1, so A2, area of sector, is given by half r squared theta. So in this case, it's half, radius is r squared, is the angle that is different, which is equal to pi over 3. So now if you multiply that area, gives you 1 over 6 r squared pi. 1 over 6 r squared pi, if you want to write it that way. So we're saying the area of that, the area of the triangle, which is root 3 over 2 r squared, minus 1 over 6, the area of the sector r squared pi. Okay, you're allowed to leave it exactly like that. Now we've got another one. It's just the same concept. Now the diagram shows you a circle with center O, a circle, center C, a circle C, sorry, with center O and radius 3 centimeters. This, okay. The radii OP, OP, and OQ are extended to S and R respectively, so that ORS is a sector with center O. Okay, that's fine. Given that PS is equal to 6 centimeters, and the area, and that the area of the shaded is equal to the area of the circle C. Show that the angle, the angle, so we don't know the angle, huh? Show that angle, we are going to apply what they've just said, that given that PS is equal to 6, and the area of the shaded region is equal to the area of the shaded region is equal to the area of the circle. Now, area of shaded region is simply equal to area of the major arc, so the area of the major sector, area of major sector minus area of small sector. So area, my pen is not writing today, it's not writing properly, so area of large sector, or RS, minus area of small sector, or area of small sector, which is OQP. So anyway, applying, so if I was to apply, they share the same angle. We said area of a sector is equal to half r squared theta. So in this case, it's simply the area that we want. It's area of the large sector. Let's say the radius of the large one is r1. So I'll write r1 theta, because they share the same angle, minus area of the small sector, I'll write half r squared. R2 is representing the small radius theta, like this. They are sharing the same angle, which means that area is simply half. The theta is the same, brackets, r1 squared minus r2 squared. Simply applying factorization from O level. So that's half the angle theta in question minus the radius is all the way from the center to that, which is 9 centimeters, minus the radius of the small one, which is 3. And that gives you 6. Okay, so you end up getting half theta multiplied by 6. So it means that shaded region there, oh sorry, I made a mistake. You are supposed to be r squared. So this is supposed to be 9 squared. Sorry guys, minus that squared. Okay, let's just do the correction there. So it's 9 squared minus 3 squared. 9 squared minus 3 squared. We get 72. So there is half theta multiplied by 72. And half of 72 is 36. So that area is simply 36 theta. Area of the shaded region, 36 theta. But they are saying that area, which we said 36 theta, is equal to the area of the circle. Area of the circle. Area of the circle from O level is pi r squared. So let's apply what we have. So it's theta multiplied by the radius, which is 3 squared, and that gives you 9 theta. And that 9 theta, which we found here, is equivalent to 36 pi. And we want to find 36 theta, and we want to find the angle, which is theta. So making theta the subject of the formula, theta is equal to 9 pi divided by 36. And 9 goes into 36, 1 over 4 pi radians. So that's how we do that. Done. Find the perimeter of the shaded region. Perimeter of the shaded region. So to find perimeter of the shaded region, it's not difficult. It's not difficult, guys. Perimeter of the shaded region. Let's agree to certain things here. Perimeter of that shaded region there. Perimeter of the shaded region is equal to length of arc. So I can say arc QP plus, follow me, arc QP there, plus PS plus length of arc is arc, major arc RS plus QR. Okay, so there are certain things that we can plug out. Okay, so maybe let's start with the length of the arc. The length of this arc here, so this we know, PS is 6 centimeters. Okay, 6 centimeters. This we are yet to find. This we know. This is 6 centimeters. Remember, radius of the large one is the same. This is also 6 centimeters. Okay, so 6 centimeters plus 6 centimeters gives us 12 centimeters for QR and PS, plus the length of this arc and the length of that arc. So the major arc, and so to find arc here, length of arc is simply QR. So we now know the angle. The angle is that. So I'm simply saying pi over 4 multiply by the radius, which is 3. So that gives me 3 over 4 pi for the small arc, for the length of the arc QP. Then the length of the major arc, S, is equal to same formula. The difference is in the radius. The radius there is 9. So we're saying theta multiplied by the radius, which is 9. Now 3 into 9, 3 times. So that gives you 3 pi. So you're saying 12 plus 3/4 pi plus 3 pi. Now if you want, you can simplify this, but we're saying 3/4 plus 3 pi. So 3 plus 3/4, 3 plus 3, that's 3 and 3/4. 3 and 3/4 as an improper fraction. 3 times that, that's 12 plus 3, that's 15 over 4. So you're saying 12 plus 15 over 4 pi. 12 plus 15 over 4 pi. If you want to leave it in that way then. Okay. Is that clear, guys? On the perimeter, show that the perimeter is equal to that. Six plus 6, 12. Let's just check something. 3/4 pi, or pi over 4. Oh, I made a mistake. My apologies. I was just checking the marking scheme. Sometimes we also make mistakes. I made a mistake there. So this angle here is pi over 4. So this is pi over 4 here. So this was not supposed to be 3. This is pi over 4 multiplied by 9. So that gives you 9 over 4 pi. So it's actually saying 12 plus 3/4 pi plus 9 over 4 pi. So anyway, this is over 4, same denominator, 12 plus 9 plus that, you get 12 pi over 4. And if you divide, you get 3 pi. So the final answer is 12 plus 3 pi. Okay, so this is the end of our first video. So you can subscribe and invite your friends. We will be loading more videos. Enjoy your weekend.